speaker will be Yuri Uno. She's going to tell us about extragalactic civilizations. Let's welcome Yuri.
Hello, I'm Yuri from National Junction University. My supervisor is Professor Hashimoto, who organized this conference. And I apologize, this talk is about the SETI, not FRB, but I hope you can enjoy. And this is kind of latest research of our group. Okay. So SETI stands for Search for Extraterrestrial Intelligence. And in a simpler words, it's just looking for aliens. And we want to find anything we can infer the technological activity from ET. And there are actually many ways to do it, but I want to focus here is detecting a radio signal from ET, which is the most conservative way as a SETI research. This is Voyager 1, and Voyager 1 is a space probe, which is the most distant human-made object in interstellar space, 160 AU away from the Earth. And this Voyager 1 has a radio transmitter that can work a small energy as small as 2 light bulbs you can buy at IKEA. And I want to ask a question here that after nearly a century of its launch, do you think this radio transmission from Voyager can be detectable? How do you think?
No.
Yes, thank you very much. Many people might think this is no, right? But
On Earth or other planets or other stars?
from us,
Us.
from
okay.
us,
Not other planet, not
yeah,
other
yeah,
stars.
sorry, from us.
Of course you can. Newspaper.
Okay. Thank you very much, Yuri. Actually, yes, as Yuri said, of course, yeah, we can detect the signal from Voyager 1, and using the current radio telescope, such as Green Bank telescope. And the light panel shows the spectral from Voyager 1, and the most distinctive feature is that signal is very narrow band. This width is less than 1 kHz. So if we detect this kind of signal, it can be distinguished with natural source. And this is the kind of signal we are looking for, expecting to detect, although we don't know what kind of signal it might send us. So this is a Breakthrough Listen project. Breakthrough Listen project is the most comprehensive radio SETI project in human history. And the goal of this project is to observe the 1 million closest stars and also 100 closest galaxies to find a signal like Voyager. Then the project is ongoing, and they have already observed 1,000 nearby stellar systems, but they reported from their initial analysis that they didn't find anything, any ET signal. Then here, let me introduce a simple metric that is commonly used in SETI field, that is transmitter rate. Transmitter rate is very simple metric. It's inverse of the number of observed stars that had no detection of radio signal from ET. So let me give you an example. We are thinking about the civilization that has radio technology and associated with our stellar system, just like Sun and Earth. And let's say we observe 4 stellar systems and we didn't detect anything. That makes us transmitter rate 1 inverse of 4, so 0.85. And we can, in other words, we can interpret it as our kind of the upper limit to the likelihood of detecting an ET signal. Okay, so from the previous research, because they reported they observed 1,000 stars and they didn't find any signal. The transmitter rate of the previous research is 0.001. That means we have less than 0.1 chance of detecting ET signal from this observation. However, there is one thing that breakthrough reason didn't take in consider when derived the transmitter rate. That is field of view. So radio telescope has field of view that is much larger than the apparent size of the target star. So when they observe a target star, they actually see their background galaxies or background sources simultaneously. So this is the actual image of a target star of breakthrough observation, and the large red circle shows the field of view of green bank telescope. And red cross marker within the field of view shows the galactic sources that is cross-matched by Garrett and Shermion. And Garrett and Shermion reported that from the all BL fields, I call BL fields this red circle. So within the all BL fields, there are 100,000 background sources. So if we think of, and then this is a figure of transmitter rate from previous researches, and green markers shows the transmitter rate reported by the Breakthrough Recent project. So if we take into account their systems reside in the background sources, the transmitter rate should be much lower. Then how lower it could be, the question we wanted to answer. And here I want to note that because the farthest transmitter, the power of the transmitter needed to be more powerful and larger in order for us to be detectable. So in our research, we are assuming kind of civilization that is advanced as their civilization that can use the power that is equivalent to star or galaxies. But we don't know if such a civilization exists or not, but it's kind of theoretically assumption. Okay. So in order to derive the number of their systems that is reside in the background galaxies or background sources, we took the two approaches. One is take the density of the stars and multiply the volume of the breakthrough recent observation. And the other is cross-matching with the galaxy catalog with BL fields and see how much mass volumes have each cross-matched galaxies. And we removed the breakthrough recent fields between galactic latitude between plus minus 20 in order to avoid the radio noisy environment. Okay, so this is the result. So we investigated the 600 BL fields. Then we kind of limited the distance to the transmitter about 1,000 megaparsec. So that makes us the such volume of the BX project to be 10 to the 6 megaparsec cubic. And the transmitter, our minimum transmitter power at 30 megaparsec is about 10 to 26 watts or 10 to the 27 watts. And the number of galaxies we found in the volume is, in the statistical method, 100,000 galaxies, and in cross-matching method, we found more than 1,000 galaxies. So the result is not, the number is a little bit different but it's okay because statistical analysis, we take into account the low luminosity galaxies that might be not cataloged in the galaxy catalog. Okay. Then we found the total mass of the star in the breakthrough recent observations. breakthroughs in volume to be 10 to the 14 in both statistical and cross-match analysis.
2 minutes left.
Thank you. Okay, so let's see the transmitter rate previously reported again. So, because we take into account the background stellar systems in the background galaxies and the of the breakthrough recent target, we get much lower the transmitter rate, which is 10 magnitude or lower than the previously reported. Okay, this is the summary. We analyzed the breakthrough recent data, and we found for the first time, we calculated the transmitter rate based on the breakthrough recent search volume. Then we found the 10 orders of magnitude stricter than the previous transmitter rate. And that's all. Thank you very much.
Thank you very much. Questions and comments, please? Any questions from online? Not yet? Any questions? Okay, Albina?
Yuri, thank you for the very nice talk.
Thank you.
Hello? Okay, so from one of your summary points is that only 1 in 100 trillions of civilizations are likely to possess a powerful radio transmitter. So what do you think? Is it very unlikely for FRBs to have been signals from aliens? I think aliens was one of the potential models in like 20 or 50 models out there for FRBs. So yeah, just wondering what's your thought on that?
Okay, thank you. In my opinion, yeah, I don't think FRB to be ET signal, but actually we have been, last week there is a new scientific paper that says they discovered the kind of candidate ET signal from breakthrough recent project. So we kind of have more stronger, more interesting more interesting object, how can I say, more interesting signal from ET than FRB. So my answer is no. Thank you.
Okay, Tete-san.
If I could one more, actually in her study, actually she assumed that this techno signature is kind of stable signature time domain. So then in FRB's case, this is a burst phenomenon. Right? So therefore, actually in order to fairly compare number density, for example, so we need to take into account this difference between these two analyses.
Thank you. Any more questions? Oh, okay, please.
Thank you. This is interesting study. So, I wonder so what's the frequency of this survey?
It's about 1 to 6 gigahertz.
So, how do we know this is the frequency band advanced alien civilization will use? Like maybe they have different atmosphere, or they might have other preferred frequency band that can do the long range transmission. So, yeah, how can we make this constraint valid? If they use a different band.
One simple answer is that because so hydrogen emission is kind of interesting to astronomers, and we kind of think ET might be also interested in the hydrogen emission that is 1.4 gigahertz. So kind of historically we want to observe between 1 gigahertz to 10 gigahertz, and we don't know what frequency they use, but historically we kind of use lower frequency than 1 gigahertz or up to 10 gigahertz.
Okay, thank you.
Thank you.
Okay, let's find Yuri-san again.